It's a crucible of creation and destruction. The name Milky Way sounds comforting and sweet. The Milky Way galaxy, however, is a beast. We live on the edge of one galaxy in a billion. Recently, we discovered that two small galaxies are colliding with each other right now. Let's make a tapestry with blinding dust and brilliant suns. It's amazing how little light we receive from the luminous Milky Way galaxy is reaching us. It's a place full of extremes. Stars can be seen drifting lazily or being flung at speeds exceedingly high. Scientists have now penetrated the heart of the galaxy to discover the Milky Way's path. If 100,000 light-years are equal in size, they will have 1 trillion times the mass of our Sun. It was created around 13 billion years ago. It's our galaxy, the Milky Way. The Milky Way galaxy has a lot of activity. It's similar to a construction job. There are always things going on. The oldest stars are destroyed, and they become new stars. The line is our solar system, and much more, right in the middle of this work zone. I believe the best way to see the Milky Way galaxy from the Milky Way is through our family of stars. These stars are the ones that travel through the universe in a clump. They orbit a common center. Its spiral arms reach far into the sky and contain clues about where we are at this point. The Milky Way stars shine like a banner across the sky on a clear summer night. The river of stars was a way to the afterlife from the ancient Egyptians. But it was first named by the Greeks. The word galagos, which is Greek for milk, gives rise to the Milky Way. We used to believe we were at the center, but we now know we are not. We see the Milky Way as a milky swath of stars in the night sky. But what we really are seeing is a spiral arm that extends from the center of our galaxy. Although we cannot see the center of our galaxy from this location, we can see one of the spiral arms, which is only a few thousand light-years closer than us. It's almost like looking at the edge of a coin. When we look at the Milky Way from our earthbound position, we don't have any idea of the true shape of the galaxy. If you view a galaxy from its top, it's a disk. It is possible to see all of its glory. It's not thin enough to see the structure, but it's still visible. The Milky Way can be compared to a city. The central region is home to large buildings, and there's lots of action in it. This is certainly true for our galaxy. You can then move to the suburbs, where you will find a more relaxed lifestyle. It's a better area to raise a child. Here is where we live. Our solar system is located in the center of the Milky Way's bustling center. Our galaxy is so vast that it takes Earth longer to reach than the Sun. However, you won't be able to see the other side of the city if you are in the middle. The population gets smaller as we move further afield beyond the suburbs. You even have some boondocks. In our galaxy, there's a halo that contains very old stars orbiting in wide orbits. The galactic sprawl does not stop at the Milky Way's undefined and loose halo. LT extends far beyond our area and out to a group galaxies called the local group. These can be viewed as counties within California if you view the Milky Way galaxy in terms of Los Angeles. This local group together makes up the whole state. The local group includes the massive Milky Way and the larger Andromeda galaxy. It also contains close to 50 smaller galaxies, some of which are quite rough. They are small galaxies. However, our local group contains a number of such galaxies that are kind of wandering about inside it. The majority of galaxies are small. The advantage of being at the outer edges of the galaxy is that you have a better view of the Milky Way outside. We can see all of the universe, including the galaxies and clusters of galaxy clusters in the neighboring galaxies. Massive globular clusters are found within the Milky Way's halo. Globular clusters are densely packed areas of stars with a similar composition. These are similar to the ethnic communities of the Milky Way galaxy. These globular clusters were formed in the very early days of the galaxy. They were among the first stars to form. Some globular clusters can be 12 to 13 billion years old. They can contain as many as 100,000 stars or even a million. The first clue to where we are in the galaxy was given by globular clusters that are almost as old and ancient as the universe. These globular clusters were visible in the sky, but their center was far from us. That was our first measurement of the location of the middle of the galaxy. They were not orbiting around us, but rather around an area approximately 27,000 light-years distant. To see our galaxy, we can't get enough distance from it. We can get a good idea of the Milky Way by looking at other galaxies and comparing our knowledge about our galaxy. We didn't know galaxies existed until we first saw them through telescopes. They were thought to be nebulae within our galaxy, but we were astonished by their beautiful spiral shape. It was only natural that astronomers would classify galaxies based on their shapes. As we can see, astronomers recognize four basic shapes in the galaxy. Elliptical is made of old stars. It has a disk with a bulge and irregular star formation. This shape is not like the Magellanic Clouds of our local group or spiral. It is a pinwheel made up of old and young stars that spins gracefully through space. People believed that an elliptical galaxy eventually collides into a spiral, or that eventually all the spirals come together to form an elliptical. It was a bit difficult to determine the sequence. We know that elliptical galaxies are very large. Centaurus A, an elliptical galaxy that is distorted and located 13 million light-years away, suggests why elliptical galactic grow so large. There is a lot of evidence to suggest that there may be a spiral galaxy there that was absorbed into a larger galaxy. It's possible, therefore, that the elliptical galaxies you see right now may be merging multiple spirals and another type of galaxies. The Milky Way is not in imminent danger of being absorbed. The heart of our spiral galaxy holds a secret. We discovered recently that the Milky Way was not a traditional spiral, but a barred one. The center has a bar of stars and the spiral arms attached to that bar. It spans 27,000 light-years and is the most famous bar in the galaxy. It attracts 30 million stars. the natural result of gravity and the gravitational interactions between the individual stars in our galaxy that make up the bulge in the disk of our galaxy, is the bar of our galaxy. Sometimes the stars can sort of get clumped together into this bar configuration when light is set. A huge central bulge lies around the Milky Way's middle. It consists mainly of stars between 10 billion and 11 trillion years old. The Milky Way's most captivating feature is the supermassive dark hole. Although it could fit easily in the space between our Sun and the Earth, it is 4 times larger than our Sun. This may sound like a lot, but other galaxies also have central black holes that can be up to 1 billion times larger than our Sun. Therefore, although we call the black hole in the middle of the Milky Way a supermassive hole among supermassive dark holes, it's actually a kind of a rant. Because light cannot escape black holes, they can't be directly seen. Astronomers discovered galactic ground zero using a radio source located in the constellation Sagittarius, also known as Sagittarius star. It is causing quite a stir. The black hole at the center of our galaxy appears to be spinning at an average speed of 1 spin every 11 minutes. It spins, and central region stars trapped in its gravity are swept along for the ride at 3 million miles an hour. The central region is most affected by the black hole. We can't feel the tug of the galaxy far from Earth, however. The unimaginable size of the Milky Way negates the immense forces at the heart of the galaxy. The name Milky Way, to me, sounds comforting and sweet. The Milky Way galaxy, however, is a beast. It is huge. When you consider how large our solar system is, the fact that the fastest spacecraft takes years to reach Saturn and Jupiter makes it seem overwhelming. If the entire solar system was the size of a CD, the Earth would be comparable in size to the Milky Way. That's huge. This is mind-blowing and never ceases to amaze me. The amazement continues. Although the galaxy's bustle may be concentrated at the center, the incredible spiral arms are able to create their own action. Here are the stars being born and stellar communities are being built. Our galaxy. It's a lot of information, and we're only just getting started to explore its depths. It is difficult to see the big picture because of our suburban location. The hazy clouds and cosmic dust block our view. The darkness is beyond the reach of even the most powerful optical telescope. If we want to know more about the Milky Way, we must look beyond what our eyes see. Despite its vastness, the Milky Way is extremely active and home to some amazing phenomena. These include star clusters and nebulas that are blazing invaders of other galaxies. Technology is causing us to rethink our old beliefs and showing us things that we have never considered before. We have ignition, liftoff, T+15 seconds. The New Horizons spacecraft is on its way to our solar system's edge. We live in a dusty world, in a dusty galaxies, in a dusty universe. It's not so empty. Optic telescopes can only see as far as the closest dust cloud, which isn't very far. However, most of our galaxy is not visible to us. This is because it is filled with dust clouds. These dust clouds block light from most stars in our galaxy. It is surprising to see how little light from the Milky Way galaxy's luminous Milky Way galaxy gets to us. It is because dust blocks the airflow. Visible light is only a tiny fraction of the energy spectrum, and radio waves rush in to reach places visible light beams are afraid to tread. Fog can make it difficult to see visible wavelengths. However, your eyes can still see them. Radio waves' ability to penetrate space dust is critical to the study and understanding of stars, but this was only accidental. Karliansky, an engineer from Bell Labs in New Jersey, built an antenna in 1933 to locate the source of static transmissions on transatlantic telephone lines. Surprised to find that the interference was coming from the central galaxy, the constellation Sagittarius, he was stunned. Scientists realized that Yansky was onto something after many decades. Radio astronomy was created because celestial bodies emit electromagnetic radiation. Radio waves were only the beginning. Technology is necessary because the human eye cannot see all of the light available. An infrared camera is a great way to see the universe in a completely different way. An infrared camera can only see the wavelengths produced by heat and then converts them to something that the human eye can view. This lens does not transmit any visible light. The lens allows heat light to pass through. Then you can see how everything looks in infrared light. In 2003, the Spitzer Space Telescope was launched into space equipped with a number of infrared camera batteries. The evolution of the universe. Its mission is to search for the youngest stars and the farthest galaxies in the universe. Although the instrument Spitzer uses are many times more sensitive than those cameras, they are basically the same. The camera does not look into the heavens, but it is used by firefighters to save people right here on Earth. Cameras can see through the smoke to detect the heat in a room. The same technology enabled Susan Stolevy, an astronomer, to see the center of the galaxy from 26,000 light-years away. This mosaic of high resolution was made from data taken from Spitzer Space Telescope. Although it sounds like a lot, it was only 16 hours of telescope time. The galactic center is a region that spans the sky and has the equivalent of 4 full moons in one direction and 3 in the other. This is equivalent to 900 light-years across at 700 light-years tall, a tiny fraction of what's available, but still a remarkable achievement. The galactic center wasn't a topic of study just a few decades back, because it was impossible to see. Visually, there is no way to see. Dust can only be penetrated by 1 light wave per trillion. However, you can still see the details if you look into infrared, radio astronomy, or X-ray astronomy, because they penetrate celestial objects differently. Different wavelengths of the electromagnetic spectrum can reveal different aspects of the galaxy. Radio waves are the shortest wavelength and have the lowest energy, but they are still used by most celestial objects. Next comes visible and ultraviolet light. Black holes and supernovas emit high-energy X-rays with wavelengths approximately the same size as an atom. Gamma rays have the highest energy because of the decay or collision of subatomic particles, such as when stars explode at billions upon millions of degrees. These waves provide astronomers with a better understanding of the galaxy's activity and shape. To study the cosmos, you will need many, if not all of the wavelengths. The electromagnetic spectrum's various wavelengths are analogous to the strings of a violin. Music uses many sound wavelengths to communicate an idea. This piece can be played in a wide range of notes, from low to high. It's almost as if we only heard two notes in the middle of a piece if we limit ourselves to the visible spectrum. Alternate wavelengths are a way to discover more. Recently, we discovered that two small galaxies are colliding with each other right now. The reason they weren't obvious to us is that there was so much dust in our galaxy that we couldn't see the stars. We live in this cloud, and we don't know it. However, infrared light can be used to cut through the dust. We saw these tiny galaxies right in front of us when we turned our infrared telescopes toward the sky. It's hard to see the true beauty of our galaxy from our position in the Milky Way. Radio and optical astronomy offer a glimpse at its features, but we must look outward to see the bigger picture. The best way to understand our galaxy is to look at other galaxies. See what they look like. Also, see things in other galaxies which correspond to what we see in our galaxy. For example, clouds of gas lined up along what appears to be a spiral arm. We can see some parts of the spiral arms in our galaxy, and we think they are connected much like the spiral arms in other galaxies. We know the Milky Way's main spiral arms extend out from the center of the city like wide streets. They are named Perseus and Normoscutum Crux Sagittarius from the inside. If the arms are the galaxy's suburbs, then the solar system lives in quiet streets between Sagittarius and Perseus, on what's known as the Orion Spur. The Milky Way stars make up a total of around 200 to 400 billion people, and they are constantly moving. We orbit the galaxy. We have changed our position. We believe the Sun has always been approximately the same distance from the center as it is now, but we have been in and out of almost every spiral arm. Density wave areas are where stars and gas are pushed together in spirals. The density waves that spiral around billions of stars pass over and through them as they ride. If you look at the Tour de France, you will see all these bikes. They are all moving forward. Sometimes they can clump together around one bicyclist. Sometimes they are stretched out. This is kind of what the spiral arms look like. They move around in the same way as bicyclists, sometimes in clumpy places and other times in more spread out areas, but they always return to the center. The stars rarely travel alone. The galaxy's halo is populated by giant globular clusters, but the galactic disk contains open or galactic clusters. These young stars are held together only by their mutual gravity. The term open cluster means that stars can move freely. It is available. This is a cluster of stars, which are usually formed from many stars. It comes together from one giant cloud of gas and dust. They will eventually move apart and spread themselves throughout the galaxy. Astronomers believe that the Pleiades is closest to Earth. Light was formed 100 million years ago. It will still be around at least twice as long before the spiral arms of the galaxy tear it apart. Our Sun may once have been part of an open cluster star, but it is now orbiting in solitude. The Sun, star clusters, our planet, and the whole galaxy are made of dust and gases. These particles, which block our view, are what brought us to this point in the first instance. The star-making machinery is still chugging. There is nothing like the sight of a beautiful sunset, but we owe it all entirely to gas and dust. For two reasons: the setting sun can appear yellow, orange, and even red. First, the molecules in the atmosphere scatter the violet, green, and blue light out of our sight. leaving only the yellows, reds, and oranges to reach our eyes. Second, blue light is more absorbent than red light because particles such as dust, smoke, and smog are present in the atmosphere. Even the grandiosity of a blue sky can be an optical illusion. Why is the sky so blue? Although there is nothing blue in the atmosphere, the shorter wavelengths of sunlight pass through it more often than the longer ones. If you look at a particular area of the sky, you are more likely to see blue lights cut towards you. Space is dark because it doesn't have enough dust particles or gas to reflect the light of a billion stars. Space is not perfect, even though it may seem like it. About 15% of the mass of the galactic disk, which is the largest part of the Milky Way, can be attributed to dust and gas. Gas clouds can cover hundreds of light years or even thousands. They provide the raw material that ignites the galaxy. These areas of cosmic dust or gas are known as nebulae and produce effects that rival anything on Earth. The Orion Nebula, a constellation in which Orion is located, is a good example. This area is active due to the stellar formation, which makes the gas surrounding the stars glow. Let's fluoresce to the light from the massive stars near the nebula. This nebula literally glows and can be seen. It is impossible with the naked eye. These are baby photos for us when we can see the Orion Nebula in person. 5 billion years ago, the sun and planets formed together under gravity. Orion is a hot star system that ionizes its gases with ultraviolet light. This is known as a diffuse or emission nebula. Astronomers also classify two additional types of nebulae. Reflection nebulae can be found in some nebulae. They are simply reflecting starlight from nearby bright stars. The Witchhead Nebula, a reflection nebula that borrows light from the star Rigel, is one example. For the same reason that our sky appears blue, reflection nebulae also appear blue. Red light is easier to reflect than blue. Last but not least are the dark nebulae such as the Horsehead. Another type of nebula forms when low-mass stars, such as our Sun, die. It is called a planetary nebula. These nebulae are dim and short-lived. But they do spew elements back into space, such as the Cat's Eye Nebula. These could be used as raw materials to create new suns or new planets. As dying stars release clouds of dust and gases, stars can also be formed. You will see old buildings being demolished and new buildings built on a construction site. It's the exact same in the Milky Way galaxy. Older stars can explode, releasing new material, gas and dust, which can then be used to make new stars. Nebulae are the galaxy's recycling centers, where old becomes new again. Recycling is more than a good idea for the planet. It is a natural cosmic law. In fact, our bodies are made of recycled material from previous generations of stars which had scattered material into interstellar space before our solar system was formed. Every generation of stars produces heavier elements that become the ingredients for everything else in the universe. The Milky Way's spiral arms are where most of the galaxy's young, hot stars are created. Gas clouds orbit the center of the galaxy as stars, but they are squeezed when they pass through a spiral arm. A spiral arm is simply a wave within the star pattern. Because stars are denser, the gas clouds that orbit them tends to become compressed. This compression allows gravity to grab the gas and cause its collapse to form stars faster than elsewhere. Because stars are more often victims of their enormous mass, they die in spiral arms. The most massive stars are very powerful and highly luminous. To be so luminous, they must use their energy very quickly. These stars are so large that they live short life and are often found near their birthplaces. While we can predict the future of certain stars, it is often difficult to know their history. New techniques reveal new information about Milky Way, a well-studied star of the Milky Way. It would be all day. The way we see life would be totally different. What are we responsible for in our current position? Scientists believe gravity is a major factor in our position. Gravity is the force that drives the galaxy, and it's at its center, where it churns out the engine it fuels. Galaxies are like a big city. They are constantly changing and being rebuilt and energized. It's clear that the Milky Way of a few billion years ago was very different from what it is today. It was probably smaller. It probably didn't have the lovely spiral shape we see today. You naturally form a disk when things fall under gravity. You will notice that there are disks all around. Our solar system is a disk, and our galaxy is also a disk. The stars then all begin to rotate in the same direction. Not all stars in the galaxy are the same as natives, just like in a city. Stars born outside the Milky Way settle in this area and make their mark. However, gravity can also affect the movement of stars in another galaxy and cause the formation of spiral arms. Our spiral shape could be evidence that the Milky Way may contain more than one small galaxy, which was formed a long time ago. The center of the galaxy was an impenetrable mystery for centuries until we discovered X-ray vision. An X-ray telescope was one of the first tools we used to pinpoint the center of the galaxy. The X-rays were able to pass through all the gas and dust in our galaxy's disk. So, although we can't see the bright center of the galaxy with X-rays and are unable to see it, there is a huge, glowing heat source in the middle. Sagittarius A is the X-ray emitter. It is also associated with the supermassive dark hole at the center of the Milky Way. The way we see life will be totally different. What are we responsible for in our current position? Scientists believe gravity is a major factor in our position. Gravity is the force that drives the galaxy, and it's at its center, where it churns out the engine it fuels. Galaxies are like a big cities. They are constantly changing and being rebuilt and energized. It's clear that the Milky Way of a few billion years ago was very different from what it is today. It was probably smaller. It probably didn't have the lovely spiral shape we see today. You naturally form a disk when things fall under gravity. You will notice that there are disks all around. Our solar system is a disk, and our galaxy is also a disk. The stars then all begin to rotate in the same direction. Not all stars in the galaxy are the same as natives, just like in a city. Stars born outside the Milky Way settle in this area and make their mark. However, gravity can also affect the movement of stars in another galaxy and cause the formation of spiral arms. Our spiral shape could be evidence that the Milky Way may contain more than one small galaxy, which was formed a long time ago. The center of the galaxy was an impenetrable mystery for centuries until we discovered X-ray vision. An X-ray telescope was one of the first tools we used to pinpoint the center of the galaxy. The X-rays were able to pass through all the gas and dust in our galaxy's disk. So, although we can't see the bright center of the galaxy with X-rays and are unable to see it, there is a huge, glowing heat source in the middle. Sagittarius A is the X-ray emitter. It is also associated with the supermassive dark hole at the center of the Milky Way. A black hole is, by definition, impermeable to light and X-rays. Radiation is caused by gas trapped in its gravity and spun to millions of degrees. They move at very high speeds. One example is that the black holes are moving at 10,000 Kelvin per second, which is the most extreme case we have seen. It's like traveling around the globe in 4 seconds. We're talking about a star that moves at that speed. It's evident that there is an invisible monster when we look at the stars that orbit the center of our galaxy. They orbit around a massive mess. The orbits of stars indicate that there is approximately 3 to 4 times as much mass as the Sun at the center of our galaxy. Although we don't know which one came first, either the galaxy or the dark hole, we do know it is there, and it's amazing. The supermassive dark hole, despite its strangeness and power, is quite typical for a galaxy as large as the Milky Way. Supermassive black hole supermassive galaxies, such as big elliptical and spiral galaxies, are also seen in the middle of other galaxies. They can range from several million times the Sun's mass up to several hundred billion. The stars around the black hole are old. Many of them are red giants that are hundreds of times larger than the Sun. They are crowded together in the galactic center like an urban center crowded with pay and apples. Stars, like people, can be pushy. The central black hole is the center of the galaxy, and most stars located in it orbit just fine. However, the galactic center is home to so many stars that they are constantly nudging one another gravitationally. Their orbits are being a bit perturbed and altered. A star bumped can lose its atmosphere, leaving only its orbiting core. Rarely, it may even fall into the black hole, disappearing. However, there is something else happening around the black hole. This dangerous, chaotic neighborhood is also a great nursery. The young stars, which have just formed, are the stars we see moving the fastest around the black holes. It's what we call the paradox in youth, because it's difficult to imagine how these young stars could be formed in the absence of a black hole, yet they are. Astronomers recently discovered that not all stars trapped in the black hole's grasp are doomed. Some people are able to see the whole universe. The galaxy's escapees are cruising through the universe at 1.5 million miles an hour hypervelocity stars. What's more, high-velocity stars are only explained by supermassive black holes. It takes very specific circumstances for a star to go ballistic. In fact, it actually requires 2 stars. Many of the stars visible in the sky aren't single stars. They are often paired or binary stars. They orbit around one another, bound by gravity's embrace. However, a star couple in the galactic center might be jostled by necrosis or stray too close to the black hole. This is the moment when the gravity of the black hole exceeds that of the stars, and the pair of stars will be broken apart. The black hole will capture one star, usually placing it in a tight orbit around the black holes. The other star will then be ejected with all its energy and will become a black hole. A high-velocity star, if the galaxy were populated by pedestrians or cars, would look more like an aircraft or high-speed train leaving the country. The ride would be incredible if you were riding on a high-velocity star. The stars would shine as brightly as the full mouth and cover every inch of sky. However, This view would rapidly change because the star with high velocity moves so fast out of the galaxy that stars will appear less and less in the night sky. The galaxy is always in motion, like a gigantic wheel or sprawling metropolis. The lone is in the center of the town. The supermassive black hole's gravity whips stars 11-minute approximately 11-minute orbit. The Earth is located at the center of the spiral arm. We traverse the Milky Way every 250 million years once we reach the end of the spiral arm. Since its formation, the solar system has only been around 18 times. It's easy to forget that the Milky Way is only one part of a vast universe because of its incomprehensible size. People often believe that the universe is expanding. In fact, I am not expanding at the moment. All my atoms have the same size. All my cells are the same size. The Earth is not moving closer to the Sun. The expansion of space is only applicable to celestial objects not bound by gravity. The expansion of the universe does not affect the solar system because the gravitational pull of the planets in the Milky Way is stronger than those outside the galaxy. Our Milky Way galaxy, a spiral galaxy, is in collision with another spiral galaxy. It is the Andromeda Galaxy. Our two galaxies could merge in 3 to 4 billion years, according to our estimates. It will be fascinating to see what happens. A collision of stars is unlikely to occur. Despite the fact that both galaxies are home to billions of stars, the distance between them is immense. They will gravitationally interact, changing their direction and moving in the same direction. The merged spirals will eventually settle down and become an elliptical galaxy. All of the galaxies within our local group will form one supergalaxy. The supergalaxy then will lose stars slowly due to gravitational interactions between the stars in that galaxy. Some of them will be flung into intergalactic space. The Milky Way formed stars quickly using the raw materials from the Big Bang when it was first formed. As the galaxy grew older, star production dropped from a few hundred per year to around 4 to 6 stars per year. The Milky Way galaxy's appearance has changed over time, and we don't know what it looked like in the past. However, it was likely that there was more gas and dust earlier, and possibly fewer stars. You had many very large, very huge stars that formed very early on. These early stars were incredibly explosive and produced new material, heavy metals that could then be used to make smaller stars of the second and third generations. Some galaxies younger than us are still experiencing this kind of building boom. Some galaxies have a higher galaxy's star formation than our galaxy. These are known as starburst galaxies. Star formation rates in other parts of the galaxy can vary from 10 to 100 times that of our galaxy. Star production slows down with each generation. The Milky Way has been around for 13 billion years. The gas being consumed is one reason why the rate of star formation in our galaxy has changed. It went from a very high to modest rate. Stars are made from gas. We're literally running out of gas. Star formation will cease completely after trillions of years. The Great Galactic Construction Project will be shut down, and the twinkling stars will disappear one by one. That's all for now. Subscribe to our other space channel and write your comments. Bye, everyone.